9.8 section and divergence of a vector field. Okay, so divergence is actually scalar. Okay, the gradient was vector, but divergence is scalar. Wow. So gradient was a from scalar to vector, right? Divergence is vector from vector to scalar. Okay, it's like, in reverse. That's very, very amazing, I mean, in sometimes, right? So it's like, it's natural extension of, one concept to the other, I guess, right? So let's see, what's the mathematical definition? So divergence of V vector field, okay, since it's a vector field, to scalar, okay? This is del, again, the del operator, okay? Dot product, something's wrong with the, V, okay? Because, it should be a scalar, we need to have dot product, right, to get scalar. That's what it is. And, each component of vector V's, you differentiate with, each coordinates and you add them up. That's the dot product of del dot product and V vector field. Okay? And I already told you that those are source and sink. The divergence, the physical meaning of divergence is source or sink. The magnitude, okay? If we write it this way, this is source, okay? So each vector represents the magnitude of the vector field itself, okay? And let's say we have, this is source, this is sink. Let's assume this. Okay? And then, this is filled, so it's like doing that, right? This is filled, so it flows from source to sink, right? Okay? That's what we use. So that divergence, the value divergence V of certain point represent the magnitude of the vector in that position. So for example, this is position P, and the calculation of, gives the magnitude, the length of that vector. Another application is this. This is flux, okay? Another application for the divergence is flux. Flux is what? When you have a flow from here to here, any fluid, water or air is flowing that direction, okay? Let's assume that. And you want to have, mathematical analysis on that, how fast the flow is, how dense, the flow is, things like that, okay? Then, what you need to do is, you have a differential box, okay? Okay? Then, what you do is this. That's what? That's what? That's sink, right? This surface, the left-hand side surface, that's flowing through, so it's sink, right? What about the other, side? It is flowing out. Oops. So it passes to go out, of that surface, right? So it's source. So this kind of fluid analysis, fluid dynamics, like, mechanical engineering. Okay? You need divergence to really make an analysis on that. All right? Divergence V is 4x minus 6y plus 16z. The partial differentiation, right? And divergence V of P is 9. You just add them. All right?